Okay, dito naman tayo sa problem 11 to 13. Okay, gate AB shown is hinged at A and kept closed by a force P at B. The pressure of the air is 18.46 kilopascals vacuum. Okay, so when it comes to vacuum pressure, yung pressure air na given dyan is equal to 18.46 kilopascals. So again, when it comes to vacuum pressure, it should be negative. So that is a negative pressure. Okay, question number 11. I determine the nearest value of the total force exerted by the oil on the plate. So hinahanap natin dito sa number 11. Let's say this is the total force exerted by the oil on the gate. So yung gate natin is 2 meters by 6 meters. So, yung previous examples natin, okay, how do we compute for the total force? Ito yung equal to gamma bar H times the area. Kaya lang, okay, kung i-recall natin yung definition ng bar H, equal ito sa distance from the location of the surface, which is a zero pressure, to the center of gravity. Pero for this example, okay, malinaw or binanggit niya sa problem na yung pressure sa air is not equal to zero. O yung pressure sa surface, okay, the surface of the oil is not zero pressure. Since okay, yung pressure sa air dito is equal to vacuum pressure, negative 18.46 kilopascals. So therefore, yung formula na to, the gamma bar H is not applicable. Pero pwede nating i-reword. Okay, ano ba yung ibig sabihin ng gamma bar H? Okay, basically, ang pressure, how do we compute for pressure? So, ang pressure is gamma H. So, anong ibig sabihin ng gamma bar H? So, we can have it as the gamma bar H, ang ibig sabihin lang nito is the pressure hanggang dun sa center of gravity. So, ni-reword lang natin, ang gamma bar H is the pressure on the center of gravity. So we can have the another form or yung ibang appearance ng formula na to. The total force is equal to the pressure on the center of gravity times the area. So basically, kailangan lang nating kunin yung summation ng lahat ng pressure hanggang sa center of gravity kung hindi zero pressure yung surface ng liquid. Okay, so we have this pressure, 18.46, negative. Ano naman yung pressure exerted by the oil hanggang sa center of gravity? So, let's say hanggang sa center of gravity, let's say this is the CG. Okay, mula sa A, okay, that is 3 meters, kalahati ng 6. So, kung mula sa surface, tayo, okay, yung height ng gate is 6 meters. Yung total height ng oil is 7. So, ito ay, supposedly, 7 minus 6, 1 meter lang yan dapat. Kalahati ng 6 hanggang dun sa center of gravity, that is 3 meters. So, yung total height ng oil hanggang dito, sa center of gravity, should be 4 meters. Okay, kunin natin yung total pressure hanggang sa center of gravity. So we have the force. That is, the force is equal to, ano yung pressure sa surface ng liquid? That is equal to negative 18.46 kilopascals. Okay, plus the pressure exerted by the oil. Ano yung pressure exerted by the oil? That is gamma H. Ano yung specific gravity ng oil? 0.8 times gamma water, 9.81. Ano yung height ng oil hanggang sa center of gravity? Yun yung kinuha natin kanina, 4 meters. So, yung portion na yan, ito na yung, yung pressure hanggang sa center of gravity. Okay, multiplied by the area of the gate. Ano yung area ng gate? That is 2 meters by 6 meters. Okay? So, kung hindi zero pressure yung liquid surface, i-reword ninyo, the total force is equal to the pressure on the center of gravity multiplied by the area of the submerged surface. So, computing for the force, okay, ito yung negative 18.46, the vacuum pressure, plus, that is 0.8 times 9.81. Okay, times yung height ng oil hanggang sa center of gravity is 4. Then, the area of the gate is 2 meters by 6 meters. So, we have that as 155.184. 155.184 kilonewtons. Okay, check natin if we have this value sa choices. 155.184. Okay, for question number 11, so pinakamalapit na will be letter B. Okay, so dito naman tayo sa problem number 12. Compute the location of the total force from A. So, let's say, okay, ito yung the center of gravity, which is, sabihin natin, that is the CG. So, alam natin na yung point of action ng total force will be on the center of pressure. So, i-assume natin na dito nag-act yung total force exerted by the oil. So, hinahanap lang natin yung distance na to. Yung point A sa figure natin is yung upper edge ng gate. So let's say from point A to the center of pressure, that is yung Z. So how do we compute for the value of Z? Okay, alam natin na yung from the upper part of the gate papunta sa center of gravity, mid-height yon, kalahati ng 6, so that will be 3 meters. So ang kailangan lang natin dito is yung eccentricity. So from A, okay, ito yung question number 12. Ang hinahanap natin dyan is yung the equivalent of Z. So the equivalent of Z is simply equal to 3 meters, kalahati ng height ng gate, plus yung eccentricity. So paano tayo nagsosolve ng eccentricity? Ang eccentricity for vertical surfaces is the moment of inertia divided by the area times the bar H. So ang problema natin dito, sa question number 11, hindi natin ginamit yung bar H para makuha yung total force. Dahil yun nga, yung surface ng liquid ay hindi zero pressure. Okay? It's not equal to 0. So how do we compute for the eccentricity? So meron tayong two possible solutions para dito. So sabihin ko na lang solution number 1. Okay, solution 1 natin is, pwede pa rin natin gamitin yung equivalent, yung force is equal to gamma bar H area. Pwede natin kunin yung equivalent ng bar H using a given force. So, gagamitin lang natin yung force na na-compute natin sa number 11. So, ito yung 100. Okay, that is equal to 155.184 kilonewtons is equal to gamma. Dapat gamitin natin yung unit weight ng liquid na ginamit dito. So, yung liquid dito is oil with a specific gravity of 0.8 times 9.81. Yun yung gamma ng liquid. Okay, multiplied by the bar H times the area. Yung area ng gate is 2 meters by 6 meters. So magkakaroon tayo ng parang equivalent na bar H pero hindi siya existing. Equivalent lang dahil lang sa force na 155.184. Okay, let us compute for that value of bar H. That's 155.84. Okay, so 155.184. This is divided by 0.8 by 9.81. Ito yung unit weight ng oil. Times the area of the gate is 2 meters by 6 meters. So this is equal to 1.648. So sabihin na lang natin 1.648 meters. Okay? So kung meron ka ng equivalent na bar H, pwede mo nang kunin yung equivalent niya na eccentricity. Okay, from this equation for eccentricity, the eccentricity is equal to, ano yung moment of inertia ng gate? Okay, that is rectangular, 2 meters wide, 6 meters deep, so 6 cubed, this is divided by 12. Moment of inertia for rectangle, divided by the area of the gate, that is 2 times 6, tapos yung na-compute natin na equivalent ng bar H, 1.648 meters. So we'll be having the value of the eccentricity equal to, okay, that is 2 meters by 6 cubed. Okay, this is divided by 12. Divided by the area of the gate, that is 2 by 6. Tapos equivalent or parang imaginary bar H, 1.648. So we'll be having a value of, sabihin na lang natin, 1.820 meters. So that will be 1.82. So ang hinahanap natin dito na distance Z, the distance from point A to the point of action of the force, or that is the center of pressure, the value of Z is equal to, yun yung mid-height ng gate na 3 meters, that is 3, plus yung eccentricity na 1.82 meters. So, a total of, yung value ng Z, sagot natin sa number 12, will be equal to 4.820 meters. So, 4.82, question number 12. So, check natin ito sa choices. If we have 4.82, okay, for question number 12, that will be letter A tayo dyan. So, yun yung ating solution number 1 kung gusto nating i-compute yung E using yung bar H. Pero non-existing yung bar H na yan, imaginary, equivalent lang dahil sa force na 155.184. Yung isang solution naman dito, okay, kung i-recall natin yung basic equivalent ng pressure, yung pressure is the force divided by the area. Or the equivalent of the area is equal to the force divided by the pressure. So sabihin na lang natin na yung area na to is yung area ng gate. I-substitute natin yung equivalent ng area na yan dun sa formula ng eccentricity. Eccentricity is equal to the moment of inertia divided by the area times bar H. So we have E is equal to yung moment of inertia divided by area is the force divided by the pressure. Yung pressure na to, i-assume natin na pressure on the center of gravity. Ay multiplied by the bar H. So we'll be having the eccentricity is now equal to pressure on the center of gravity multiplied by the moment of inertia divided by the force times the bar H. Okay, i-recall natin, anong equivalent ng pressure on the center of gravity? So we have E is equal to, that is yung gamma bar H times moment of inertia, divided by the force bar H. So dito, we can cancel yung bar H. So yung isa pang equivalent ng eccentricity, kapag vertical surfaces, ito yung unit weight ng liquid, moment of inertia divided by the total force. Okay? Applicable lang ito for, again, the vertical surfaces. Kung hindi mo naman kailangang isolve yung bar H, or kung hindi mo naman gagamitin yung bar H, you can use this formula. Diba kasi sa question number 11, sa question number 11, di naman tayo nag-solve ng bar H. So, what if hindi mo siya kailangan? Pwede mong gamitin ito directly. Let us solve if we are to arrive with the same value of eccentricity. Okay, so we have the eccentricity is equal to the unit weight of the liquid, moment of inertia, divided by the force. So, yung E nito is equal to, ano yung unit weight ng liquid? It is oil with a specific gravity of 0.8 times gamma water, 9.81. Ano yung moment of inertia ng gate? Ito yung 2 meters by 6 meters cubed divided by 12. The BD cube over 12. Tapos yung force na nakuha natin is 155.184 kilonewtons. So, let's say E is equal to, this is 0.8 of the 9.81. Okay, moment of inertia is 2 times 6. Okay, this is cube divided by 12. Okay, all over. Okay, the force na na-compute sa number 11 is 155.184. So, that's the same as 1.82 meters. So, pareho lang yung nakuha natin kanina. Pero yung pinakasagot natin dito, dagdagan lang natin ng 3. Okay, that will be the distance of the force from point A, 4.82. Okay, so this is equal to 4.82 meters. Okay, dun sa question number 12. Okay, then proceed tayo sa question number 13. Okay, which of the following gives the value of the force needed to keep the gate closed? Okay, so kung babalikan lang natin yung figure, okay, so ito yung force natin. Na-compute natin ito sa question number 11. Yun yung 155.184 kilonewtons. Tapos, yung location ng force F na to is at a distance of 4.82 meters. Yun yung Z kanina sa number 12 from point A. So, hinahanap lang natin yung force dito sa point B that will keep the gate close. So, ang pwede lang naman natin gawin dito is simple mechanics. Pwede natin gawin is the summation of moments at A equal to 0, assuming clockwise moments to be positive. So, ano yung mga clockwise moments? Ito yung force doon sa B. Sabihin ko na lang, force B. Ito. So, this is the same as the force at B. So, ang lever arm niya, gaano siya kalayo from point A? Yun yung height ng gate. That is 6. Minus yung total force exerted by the oil, gaano siya kalayo from A? Yun yung Z kanina sa number 12. Equal to 0. So, we have the force at B times 6 minus the total force exerted by the oil, 155.184 kilonewtons. Gaano yun kalayo from A? Ang na-compute natin kanina is 4.82 meters. Equal to 0. So, computing for the force at B. Ito yung question number 13. So, that will be the same as 155.184 kilonewtons. Gaano yun kalayo from A? 4.82. To be divided by, gaano kalayo si point B? That is 6. So, we have that as 124.66. 124.66 kilonewtons. So, this will be our answer for question number 13. Pero kung titingnan lang natin ng konti, ano yung pinakamalapit sa choices? That will be letter A. 124.68. Baka iba yung ginamit niya dyan. Palitan ko lang. Baka ang ginamit niya is yung 2 decimal lang ng force. 155.18. Check natin. Yun lang din naman. So, pero anyway, ang sagot natin will be 124.68 kilonewtons. So, yun na yung pinakamalapit na value. So, this will be our solution for problem 11 to 13. Ito yung case na kapag hindi zero pressure yung liquid surface. Okay, so dito tayo sa problem number 14. A triangular plate 1 meter wide at the base by 2.4 meters high is submerged in water, with its base 2 meters below and parallel to the water surface. How far below the centroid is the point of action of the hydrostatic force? So, how far below the centroid? Okay, kung i-base natin dito sa tanong, below the centroid is the point of action of the hydrostatic force. Basically, yung hinahanap natin dito is yung the eccentricity. So, for example, ito yung figure natin. So, meron tayong triangular plate. So, 1 meter base, 2.4 meters yung height. Yung kanyang base will be 2 meters below the water surface. So, for example, nandito yung kanyang center of gravity. I-assume naman natin na nandito yung center of pressure. So we are looking for this distance, okay, the eccentricity. Okay, so alam natin na kapag triangular yung section, yung location ng kanyang centroid will be 1/3. So 1/3 mula dun sa isang side, yun sa 1 meter na side. So that will be 1/3 of 2.4, and this is yung given kanina na 2 meters. Yung total distance na to will be the bar H. Okay, so anong equivalent ng bar H natin? So we have the bar H is equal to yung 2 meters plus the location of the centroid, okay, from the base, that will be 1/3 of 2.4. Okay, 1/3 ng 2.4, I think that is 0.8. So yung bar H natin will be equal to 2.8 meters. Then for the moment of inertia, okay, di ba pag triangular, ang moment of inertia is the BD cube triangular over 30, okay, over 36. Okay, so the base is equal to 1 meter and the total height of the triangle is 2.4 meters. Okay, compute natin yung required dito, yung eccentricity. That's equal to the moment of inertia divided by the area of the section times the bar H. So we have now the eccentricity is equal to moment of inertia. The base is 1 meter. We have a depth of, yung depth niya is equal to 2.4 meters cube. This is divided by 36 all over. Ano yung area? That is 1/2 of the base, 1 meter, a depth of 2.4 meters. So area ng triangle, 1/2 base times height, times the bar H na na-compute is equal to 2.8 meters. By computing for the eccentricity, okay, that is 1 times 2.4. This is raised to 3. This is divided by 36. Then the area is 1/2 of the base. Okay, we have a base of 1 meter. A total depth of the triangle is 2.4 meters. Then yung bar H is 2.8 meters. So that's equal to 4 over 35 or equal to 0.114 meter. Okay, so that's 0.114. Okay, 0.114 meter. So check natin kung meron tayong value nito sa choices. Okay, for problem number 14, 0.114, that will be letter A tayo. So ito yung solution natin sa problem number 14. Lumabas na rin ito one time sa board exam. Dito naman tayo sa inclined surfaces. For example, meron tayong submerged plate pero naka-incline siya. Let's say the inclination with respect to horizontal is theta. So yung direction ng force will be also inclined dahil yun nga, naka-incline yung submerged surface natin. So paano ba mag-compute ng hydrostatic force sa ganitong case? Okay, pareho pa rin dun sa vertical surface. Ito yung hydrostatic force is equal to the gamma, unit weight of the liquid, multiplied by the bar H times the area. Applicable pa rin ito. As long as kailangan lang nating illocate yung center of gravity from the free surface, considering yung free surface ulit ay zero pressure. So, meron tayong bagong variable dito. Ito yung bar Y. Yung bar Y naman is yung distance from the center of gravity to the liquid surface with zero pressure along with the inclination of the submerged plate. So, kung mapapansin niyo, makaka-form tayo dito ng triangle. Ano yung relation between bar Y and bar H? So, yung bar Y will be the hypotenuse of that right triangle. So, we can use the function of sine of theta. So, the sine of theta is equal to opposite. Ito yung bar H divided by the bar Y. Yun yung relation ng dalawa. The bar H and the bar Y. So, since incline yung surface natin, how do we compute for the E this time? Yung eccentricity. So the eccentricity is equal to, this is the moment of inertia, ay divided by the area times, this time, hindi siya bar h, gagamit tayo ng bar y. So E is equal to the moment of inertia divided by area times the bar y. Okay, yung isang case na ginawa natin kanina or doon sa previous example natin is yung pressure is equal to the force divided by the area. Or we can have the area equal to the force divided by the pressure. Okay, so pwede natin gawin dito, we can express the equivalent of the bar y in terms of the bar h. So, ang equivalent ng bar y is the same as the bar h divided by the sine of theta. So, input lang natin yung equivalent ng area dito at saka yung bar y. So, mag-substitute tayo dito sa formula ng eccentricity. That is yung E equal to the moment of inertia divided by area. Ito yung force divided by the pressure times ang equivalent ng bar y. Ito yung bar h divided by the sine of theta. Kung isi-simplify natin ito, this will be the same as pressure. To be specific, ito yung pressure on the center of gravity times I, tataas din yung sine theta. Times the sine of theta all over the force multiplied by the bar h. Okay, so mag-simplify tayo. We have the equivalent of the eccentricity is now equal to ang equivalent ng pressure on the center of gravity. Ito yung gamma bar h times the moment of inertia sine of theta. This is divided by the force times the bar h. So we can cancel yung bar h. So yung formula natin para dito, just in case hindi tayo gagamit ng bar h or bar y, eccentricity can be computed as E gamma of the liquid, moment of inertia, the sine of theta, this is divided by the force. Okay, so again, ano yung limitation nito? Applicable siya kapag incline. Ano yung pagkakaiba niya dun sa vertical from our previous discussion? Kapag vertical, yung E is equal to gamma times I divided by the force. So ito naman kapag vertical. Just in case na ayaw natin or hindi natin gagamitin yung bar h or bar y. Okay, so let's have an example for this case, the inclined surfaces. Okay, dito tayo sa problem 15 to 17. A rectangular gate 1.2 meters by 3 meters is acted by water on one side and is positioned with its longer sides parallel to the water surface. And the plane of the gate is inclined at 60 degrees with the horizontal. The top of the gate is submerged 2 meters vertically below the water surface. So, question number 15, compute the total hydrostatic force. So, ito yung ating figure. So, ito yung gate. That is, yung base natin this time will be 3 meters. Kasi sabi niya sa problem, with its longer sides parallel to the water surface. So this time, yung B natin is 3, yung D natin is 1.2 meters. So how do you compute for the hydrostatic force? Applicable pa rin dito yung sinabi natin na the force is equal to gamma bar h times the area. Since wala naman siyang binanggit kung may pressure sa surface, pwede nating i-assume that basically, the pressure at the surface is equal to 0. So all we need is, kailangan lang natin ito, yung vertical distance from the liquid surface directly to the center of gravity. So ito yung the bar h. So meron na tayong initial depth na 2 meters. Okay, kunin lang natin yung distance na to. Vertical distance from the center of gravity to the top of yung upper edge ng gate. So, ilagay na lang natin siya as W. Yan. Hindi. Ibang letter na lang. Let's say, Z. So, kailangan lang natin yung distance Z na yan. From the center of gravity, vertically papunta dito sa upper edge. Kasi basically, yung equivalent ng bar H dito is simply equal to yung 2 meters na to plus yung ay yung Z. So, di ba yung center of gravity, ito yung ating plate, yung center of gravity is obviously 0.6 meter from one end. So, 0.6 meter, 0.6 meter. So, the inclination is, ay given ito, yung inclination ng plate is 60 degrees. Ay, yung nilagay ko na vertical height dito is yung Z. So, therefore, ay, ano yung function na pwede kong magamit para makuha yung value ng Z? I can use the function of sine. So this is the sine of yung given na angle is 60 degrees. Ay, that is equal to opposite. Ito yung Z divided by hypotenuse 0.6. So the value of Z is equal to, so that is the same as 0.6 the sine 0.6 the sine of 60 degrees. Okay, so yung lumabas dito is 0.5196. Okay, so lagyan na natin 0.5196. Ano ba? 0.5196 meter. So 0.5196 meter. So, yung equivalent ng bar H, okay, this is for question number 15. Okay, the equivalent of the bar H is yung initial 2 meters, yung lalim ng upper edge. That is 2 meters plus yung value ng Z, 0.551, 96 meters. So, let's say the value of the bar H is equal to 2.5196 meters. Ayun. Kung alam na natin yung value ng bar H, we can have the equivalent of the total hydrostatic force. So this is water, 9.81 kilonewtons per cubic meter, times yung na-compute natin na bar H is 2.5196 meters. Ano yung area ng gate? It is 3 meters by 1.2 meters. So, computing for the total hydrostatic force, so that will be 9.81 multiplied by yung ating bar H, 2.5196 multiplied by the area is 3 by 1.2. So we have that as 88.982. So we have 88.982 kilonewton. So let us check kung meron tayong ganitong value sa choices. 88.982. Okay, so I think we can have letter A. Ito yung 88.98 kilonewtons. Then for number 16, locate the point of action of the hydrostatic force from the bottom of the gate. So, let's say, ito yung hinahanap niya dito. So, for question number 16, so, ilolocate lang natin yung hydrostatic force mula dito sa ilalim ng gate. So, ano yung variable na pwedeng gamitin dito? Let's say, I'll be using x naman ngayon. So, how to compute for the value of x? So, dito tayo sa parang may equivalent niya na mas malaking figure. So, mula dito sa ilalim ng gate, alam natin na yung distance papunta sa center of gravity ay 0.6 meter. Okay, so kung sasabihin natin na nandito yung lipat natin. Okay, so again, mula dito sa ilalim ng gate, papunta sa center of gravity, this is 0.6 meter. Okay, alam natin na yung point of action, the point of action of the hydrostatic force is on the center of pressure, which is, ang distance nito, ang distance niya is the E from the center of gravity. So, yung hinahanap natin dito na value ng x, okay, ano yung equivalent ng x basically? So, yung equivalent ng x dyan, for question number 16, Yung question number 16 is, the value of x is equal to 0.6, yung kalahati nung, yung depth ng gate, minus yung eccentricity. So therefore, kailangan natin kunin yung eccentricity. How do you compute for the eccentricity? Ito yung E equal to, okay, that is the moment of inertia of the section divided by the area times, okay, the bar Y. So kung pwede tayong gumamit ng bar Y, okay lang din naman. Or pwede rin naman natin gamitin yung gamma moment of inertia, the sine of theta divided by the force, since meron na tayong force. Okay? So computing for the value of the eccentricity, para hindi na natin kunin yung bar Y, okay, gamma, this is water, 9.81. Moment of inertia, take note na ang base natin this time is 3, ang depth natin ay 1.2 cube. So rectangular, okay, BD cube over 12. So that is the moment of inertia, the sine, ang inclination ng gate ay 60 degrees. Given yon. Divided by the force. Ano yung force na na-compute natin sa number 15? Okay, ito yung 88.982 kilonewtons. So, yung lalabas na unit ng eccentricity dito should be in meters. So, ginamit ko na lang yung gamma I sine theta over F para hindi na tayo mag-compute ng bar Y. So, we have, that is gamma, 9.81, gamma water, times, okay, that is the moment of inertia. Ang base is 3. Yung depth natin this time is 1.2. This is cube. Okay, divided by 12. Okay, then the sine of 60 degrees, okay, all over. The force, 88.982. Oh, syntax error. Okay, dun tayo. So that's equal to 0.0412. 0.0412 meter. Check natin ulit. 0.0412 meter. Okay? So, again, ano yung hinahanap natin dito? That is the value of x. Gaano kalayo yung point of action ng force from the bottom of the gate. So, we have the value of x is now equal to, okay, mid-length or mid-depth ng gate, 0.6 minus eccentricity is 0.0412 meter. So, ito yung required sa number 16. We have the value of x is equal to, okay, para mas sakto, gamitin natin yung stored value, 0.6 minus the answer. That is equal to 0.5587. So, sabihin natin 0.5588 meter. Okay, 0.5588 meter. So, let us check kung meron ito sa choices. That is for question number 16. 0.5588. Okay, pinakamalapit na dito for question number 16 will be letter A, 0.559 meter. Then, question number 17 tayo. If the gate is hinged at the bottom, okay, compute the force to be applied at the upper edge required to open it. Okay, so sabi niya, kung naka-hinge daw dito sa ilalim, so parang maglagay tayo ng hinge dito. Sabihin na lang natin, this is at A. So, tinatanong, ano daw yung required force na pwedeng i-apply dito sa taas para mabuksan yung gate. So, ano bang ipapangalan natin sa force na to? Let's say this is point B this time, point A sa baba. So, kung mag-a-apply tayo ng force dito para buksan, let's say the force at B, what will be this value? So, by mechanics, okay, so mag-a-apply lang tayo dito ng konting mechanics. So, this is for question number 17. Ang gagawin lang natin dito is the summation moment at A, yun sa ilalim, sa hinge, equal to 0, assuming clockwise moments to be positive. Ito yung ating clockwise moment, yung hydrostatic force, gaano kalayo from the bottom of the gate. yun yung X, required sa number 16. Minus, yung force sa B, let's say this is the force at B, gaano siya kalayo from the bottom of the gate, obviously, okay, yung total depth ng gate natin is given as 1.2 meters. So, multiplied by 1.2 equal to 0. Pwede rin kayong mag-trial and error pag ganito yung problem. Di ba yung force F is number 15, yung distance X is number 16, yung force at B is number 17. So kung tiningnan natin ng maigi yung third question, pwede kayong mag-trial and error. Kailangan nyo lang isatisfy yung equation na to. So we substitute. Okay, ano yung force or the hydrostatic force? That is 88.982. So we have that as 88.982 kilonewtons. Ano yung value ng X? Yun yung required sa number 16 kanina. Okay, yung 0.5588. That is 0.5588. Then minus, the required is the F sub B, okay, multiplied by 1.2 meters, equal to 0. So, ito yung applied force dito sa taas, minimum force para mabuksan yung gate. So that is 88.982 ay multiplied by 0.5588 all over, we have 1.2 meters. That is 41.436, 41.436 kilonewtons. Okay, tingnan natin yon sa choices if we have this value. Okay, pinakamalapit na 41.436, so closest value. That will be letter B, 41.45 kilonewtons. Okay, for question number 17. Check lang uli natin. 41.436. Pero for just in case gamitin ko yung mga nasa choices. Okay, 88.98 lang yung 15, 0.559 naman sa 16, 15 tsaka 16. Yun yung 41.449. So approximately 41 yan, yung 41.45 dito sa number 17. So this will be our solution for problem 16 to 17. Problem 18 to 20. The tank shown is 3 meters wide into the paper. Unit weight of water is 9.79 kilonewtons per cubic meter. So let us imagine perpendicular to the paper, the width of this tank, the width is given as equal to 3 meters. Tapos yung binigay na gamma water dito, actually may mga passboard na ganito yung given. The unit weight of water is given as 9.79 kilonewtons per cubic meters. Ito muna yung gagamitin natin. Okay, so ito yung parang quarter circle gate AB. So obviously yung kanyang radius, the radius of this quarter circle AB, the radius is equal to 5 meters. So required question number 18. Determine the vertical component of the total hydrostatic force on the quarter circle panel AB in kilonewtons. So how do we compute for the vertical component of the hydrostatic force? Okay, for this problem, walang in-indicate or walang sinabi na may pressure sa surface, kaya we assume that the pressure is equal to 0. So for this case, ano ba yung appearance ng hydrostatic force? So naka-incline siya since this time, we have a curved surface. So, kapag naka-incline yung force, meron siyang vertical component. Meron siyang vertical component. Sabihin na lang natin that F sub B. And meron din siyang corresponding horizontal component. Yun yung F sub X. Okay, yung required lang sa number 18 is yung vertical component ng hydrostatic force. The vertical component, F sub B. So how do we compute for the vertical component? Ang vertical component ng hydrostatic force is equal to the weight of a liquid above the gate. The vertical component is equal to the weight of the liquid above the gate. So we have that as F sub B equal to the weight. Paano ba tayo mag-compute ng weight? Kung i-recall natin yung fundamentals, ito yung unit weight of the liquid times the volume, the gamma volume. Okay, so parang ang gagawin natin dito, i-isolate natin yung liquid directly above the gate. So, burahin muna natin ito. So, we have, parang maglagay tayo ng parang imaginary boundary. Okay, para ma-separate natin yung parang liquid directly above the gate. So, ito, yung liquid directly above the gate, pwede nating i-separate into two sections. Yung isa is rectangle, that is 5 meters, yun yung radius ng quarter circle. The radius 5 meters, tapos yung height niya will be 4 meters. While yung ibang part ng liquid will be, ito, yung quarter circle. So, kunin natin the vertical component of the hydrostatic force. So, we have F sub B. That is, F sub B is equal to the weight. Okay, gamma, take note, gamitin natin yung gamma na given dito. That is equal to 9.79 kilonewtons per cubic meter. Ano yung volume above the gate? Unahin natin yung rectangular portion. Ito yung 5 meters. So, ito yon. So, that is the 5 meters by 4 meters. Then, multiplied by perpendicular sa paper. Okay, that is yung width, that is 3 meters. Para maging volume. So, 5 meters by 4 meters by 3 meters perpendicular to the paper. Yun yung rectangular part. Doon sa quarter circle part naman, that is plus, we have pi. Ano yung radius ng quarter circle? That is 5 squared. Quarter divided by 4. Okay? So, that is yung area ng quarter circle. Para maging volume, multiplied by 3 meters perpendicular to the paper. So, obviously, yung unit din nito ay nasa cubic meter. So, cancelling yung cubic meter na unit. So, ang may iwan dito for the hydrostatic force, vertical component of the hydrostatic force will be in terms in kilonewtons. So, computing for that value, so, ito yung 9.79, okay, multiplied by, ano yung volume ng rectangular portion. Doon tayo sa rectangular portion, ito yung 5 by 4, perpendicular to the paper, 3 meters. Plus, yung quarter circle na part, that is pi, the radius is 5 squared. Quarter divided by 4, yun yung area. Okay, multiplied by 3, perpendicular to the paper, para maging volume. So, we have that as 1,164.079. So, that is 1164.079 kilonewtons. So, check natin. Tama ba kung yun? We have 1164.079. Okay, check natin yung value na to if we have that in our choices. Okay, so pinakamalapit na sa choices natin will be letter B. 1,164.08 kilonewtons. Okay, question number 19. Determine the total hydrostatic force acting on the quarter circle panel AB. So, yung binanggit ko kanina, para makuha natin yung total hydrostatic force F for a curved surface, kailangan natin yung dalawang components. Okay, yun yung vertical component which is nakuha na natin. Okay, for question number 19, for the total hydrostatic force for a curved surface, ito yung resultant ng vertical component at saka yung horizontal component. So, meron na tayong vertical component, 1164.079. So, paano naman natin kukunin yung horizontal component ng hydrostatic force? Ito yung F sub H. Okay, how do we compute for the F sub H kung ang vertical component ay weight ng liquid? Paano naman siya? Ito yung horizontal component F sub H is gamma bar H times area prime. So sabihin natin na yung area prime, ito yung vertical projection of the curved surface or yung gate. So yung parang yung A prime natin this time is the vertical projection of the gate. So ano ba yung appearance ng gate natin? For example, ay nandito yung line point of view natin. Okay? So kung dito ka nakatingin, ano yung appearance ng curved surface na to? So basically, ang appearance niya is para siyang rectangular gate lang. So, yung rectangular gate na to is meron siyang height na, yun yung radius, 5 meters. Meron siyang width na 3 meters perpendicular to the paper. Okay, yan yung appearance niya. Yun yung kanyang vertical projection. Okay, yan yung ating A prime. So, kailangan natin kunin yung equivalent ng kanyang bar H. So, ang bar H is, ilolocate lang uli natin yung imaginary center of gravity papunta dito sa surface. So, ano yung value nito? This will be the bar H. So, ang bar H is simply equal to, okay, so meron tayong initial dito na height na 4 meters, that is 4, plus kalahati ng 5 meters, that is 5 over 2. So, ang equivalent ng bar H will be equal to, so 4 plus 2.5, that will be 6.5 meters. Okay? So, compute muna natin yung horizontal component of the hydrostatic force. So we have, this is the F sub H is now equal to gamma. So gamitin natin yung given, the 9.79 kilonewtons per cubic meter. Bar H is 6.5 meters. Ano yung ating area prime? Ito yung 3 meters by 5 meters. So 3 by 5 meters. So this will be the horizontal component of the hydrostatic force. So, F sub H equal to ay 9.79 times bar H, 6.5. Area prime natin is 3 meters by 5 meters. So, this is equal to 954.525. So, 954.525 kilonewtons. So, computing for the total hydrostatic force, resultant yun ng dalawang component, F is equal to the square root of ano yung ating vertical component. The vertical component is 1164.079 squared. Horizontal component is 954.525 value squared. The total hydrostatic force now equal to is 954.525 squared plus 1164.079 squared, then square root. That's 1,505.39. Ay 1,505.39 kilonewtons. So, check natin if we have this value for question number 19. 1505.39 kilonewtons. Ay, that will be, sa choices natin, that's letter D. Then, question number 20, ay calculate the angle that the resultant hydrostatic force makes with the horizontal. Okay. So, for question number 20, based sa mga direction na given, or based direction na direction ng mga components natin. So ito yung parang direction ng hydrostatic force acting doon sa gate, downward to the right siya. So ito yung kanyang vertical component, downward, F sub B, horizontal component to the right, F sub H. Hinahanap lang natin yung angle theta. So dito we can use tangent, the tangent function, para gamitin natin yung mga components. Okay, the tangent of theta is opposite. Ito yung vertical component divided by the horizontal component. Yun yung adjacent side. We have the tangent of theta is now equal to f sub b. That is 1,000. Ay, 1,100. 1,164.079 kilonewtons divided by yung nakuha natin kanina na horizontal component. We have 954.525 kilonewtons. So, kunin natin yung angle. So, this will be shift tangent of 1164.079. Hindi ko nilagay yung point. 0.079 ay divided by 954.525. That is 50.649 ay 50.649 degrees. Tama ba? Ay 50.649 degrees. So, check natin ito sa choices for question number 20. Ay 50.649, that will be letter A, 50.65. So, this is a passboard exam problem. Ay, example natin for the case of submerged na curved surface.